Hello all, welcome back to my channel. Today in this session we are going to take up a question from shortest seek time first. This is a question which comes in operating system where you get some numericals on disk schedulers. So wherein you are given some tracks, platters and some information of the movement of head from one track to another, from one sector to another, and you need to compute the total time, or basically you need to compute various metrics. When sometimes they ask about time that it takes, sometimes they ask about the number of movements it takes, and so on. So this is one of such questions. We have already taken up or seen various questions from gate topic, and we have done various questions on that. Now this one is from gate 2018, and a unique point over here was the information about the sector, cylinder, and the platter. All three informations were given over here. So this was a bit complex to appear, but it was very simple when we solved this, and we'll see how we solve this in a very simple manner. So let's see how we solve this question. So let's quickly get into the question. Let's see what was given and what needs to be found. So here they give that consider a storage disk with four platters numbered from 0 to 3, which is 0, 1, 2, 3, 200 cylinders numbered from 0, 1, so on till 199, and 256 sectors per track, which is 0, 1, so on till 255. The following six disk requests of the form sector number, cylinder number, and platter number are received. So they have given these requests which have been received by the disk controller, and what they ask is that currently the head is positioned at sector number 100 of cylinder 80. So at 80th cylinder, sector number 100 is where the head's current position is, and it is moving towards higher cylinder numbers. That means basically the direction is also given. So since it is moving towards higher direction numbers, higher cylinder numbers, so therefore it is moving to the right hand side. So from 80 it is moving towards right, towards higher cylinder numbers. Let's say 90 is here, then 100 is here, so it is moving toward right. The average power dissipation over here is moving the head over 100 cylinders is 20 milliwatts, and for reversing the direction of the head movement once is 15 milliwatts. Power dissipation associated with rotation latency and switching of head between different platters is negligible. So what is required is to find the total power consumption in milliwatts to satisfy all the disk requests using the shortest seek time first disk scheduling algorithm. So the algorithm is given which is shortest seek time first, and they have asked us the total power consumption that will occur after solving all these requests. So now what happens in shortest seek time first, we very well know that we serve the request uh, to reach which we would have to um, count the minimum number of steps, you can say, or we would the to reach the request that would occur in the minimum distance of reach from our current position. So that is the basic logic behind shortest seek time first disk scheduling algorithm. Now another important point over here is that a lot of information is given in the question. They have given you the sector number, cylinder number, and platter number, but you need to find out that what is essentially required. See, you are going to serve the request in the form of cylinders, right? So you are going to talk in terms of cylinders only. They are not asking you that how much uh, platters have you covered, how much sectors have you covered, so on. So the other extra information is essentially to confuse you over here. No other relevance is here according to me. So how we solve this is, again, you just forget about the entire part of the extra information, just think about the cylinders, the order of the requests in the form of cylinder numbers. Once you have the particular serving order, then you use that information to compute this over here, that the uh, power consumption that is going to take place. So that is the entire logic of this question. So let's see how we solve this one now. So first, our approach is same. Again, we have discussed a lot of questions on this, and you may view the previous questions for your practice. So in this particular question also, we are going to apply the same approach. We just draw basically a number line sort of thing, and wherein we list the cylinder numbers over here, and then we see how we serve them. So over here, first of all, in the center, I have written this 80 cylinder number, since the head is currently in this position. So I'll take something different. Yeah. So since the head is currently in this position, so this is the center marked. Then after this, I have a number of requests, so I arrange them in the form of a number line. Like for example, all the cylinder numbers with cylinder number higher than 80 are going to be on the right hand side, and the ones which are lower than 80 are going to be on the left hand side, all arranged in increasing order, right? Because it is in increasing order as it is on a number line. So after we are done with this, now we see which ones are to be served in which order. So first I am on 80. Now either I can go on the left hand side to serve this 72, or I can go on the right hand side to serve this 86. Now you see the distance. Now how do you take the decision, right? You need to check which is the algorithm on the basis of which you need to serve. So the algorithm is shorter seek time first. So therefore you have to check for the distance, and then you have to take the decision. So if you check the distance between 80 and 86, it is 6, right? And between 80 and 72 it is 8. So therefore you'll serve 86 only. So no direction changes involved over here. So we serve 86. Then we check the distance in the similar manner. We check the distance between 86 and 116, which is 30, and we check the distance between 86 and our next on the left hand side, which is 72, right? So 8 plus 6, this is 14. So obviously the distance on left hand side is less, so that means the next request that we're going to serve is 72. Okay, next we are going to check the distance now again. So between 72 and 20, which is 52, and between 72 and 116, right? So just a few. This is 44 over here. So obviously the distance on the right hand side is less now, so therefore we are going to serve the request of cylinder 116 first. Then again we check the distance. We check the distance over here, which is what? 134 minus 116, which is 18. And the distance between 116 and the next request that needs to be served is 20, which is far much more than 18. So 116 minus 20 is 94. So obviously we're going to serve the request over here on the right hand side, which is this one, 134. Now after this, we are going to return on the left hand side to serve 20, because either we can serve 20 or we can serve 16. So 20 is closer than 16. So first we serve 20, and then at the end we serve 16. Okay. So once we have this order of serving these requests, then what is the next step? Then we need to compute the power dissipation, and to compute that we need to check the question which says over here that the average power dissipation in moving the head over 100 cylinders is 20 milliwatts. So we need to now check the cylinder counts, the movements of cylinders that took place in order to serving this request. So very simple over here, you check the cylinder counts, and that is what? 86 minus 80, right? Plus you just add up all the counts in the same order in which you served. So 86 minus 72 plus 116 minus 72 plus 134 minus 116 plus 134 minus 20 plus 20 minus 16. Hello. So once you sum this up, this entire thing comes equals to 200. So we had just computed the stepwise, the elementary differences over here above. So you can just add them up and you'll get 200 over here. Then the question will check what is the power dissipation logic that they've given. So they've said that for 100 head movements, you have 20 milliwatts of power dissipation. So just check over here for 100, there is for 100 movements, you have 20 milliwatts. So therefore for 200 it will be what? Just double of it, so 40 milliwatts, right? You can also use the unitary method to do that. Like for 100 it is 20, so for 1 it will be 20 by 100, and for 200 it will be 20 by 100 into 200. So this way also it comes out to be 40. And now other thing is that they also said that when you change the direction, then also power dissipation occurs. So they say for every direction change, 15 milliwatts of power dissipation occurs, as it is written over here. So we'll check the number of direction changes that we have done. So this is 1 over here, 2, just 1 direction change over here, second over here, third and fourth. So there were 4 direction changes. So therefore we have 40 plus 4 into, it was 15 for 1 direction change. So this is 40 plus 15, 4s are 60, which is 100 what? Milliwatts of power dissipation. That is the answer for us. Let's see what is the format required. So they've not written any format over here, so you can just say, yeah, they said in milliwatts, power consumption in milliwatts. So the answer over here is 100. So that's all for this session. Hope you found it informative. In case you did, please press the like icon below. I'll see you all in the next video. Till then, stay tuned, keep learning. Thank you. Hope you liked this video. In case you did, please don't forget to like the video and subscribe to support the channel. Also, if you're the one who has not subscribed to my channel but would like to see more of such videos, please press the subscribe icon and also click this bell icon to get notified with my latest videos. Share as much as you can to spread the knowledge to the world. I'll be back with more of such videos. Till then, stay tuned, stay healthy, keep learning. Thank you.